Good evening. Welcome to GATE class. In today's GATE class, we are going to discuss few problems in complex analysis. Question number 1. So all these questions what we are going to discuss today, they were taken from previous year's GATE question paper. Now let us move into the first question. Which one of the following functions is analytic over the entire complex plane? So this is basically a multiple choice question which carries 1 mark, and we have 4 choices. Choice A, log z. Choice B, e power 1z. Choice C, 1 by 1 minus z. And choice D, cos z. Now before answering this particular question, let us see what is analytic function, what is entire function, and we are going to see a few relevant topic to the analytic function. So let us see what is entire function. A function which is analytic everywhere in the complex plane is called entire function. That is, the function f of z must be analytic at every point in the complex plane. And we will see what is analytic function. Analytic function is nothing but it is a function which has got single valued. That is, for every point in the domain, it has a unique image in the codomain, and the function has got unique derivative at each point of the domain. Or in simple words, I can say analytic function is a function which is continuously differentiable at every point in the given domain. Now we will see what is the necessary condition for a function f of z to be analytic. A function f of z equals u of x comma y plus I v of x comma y is said to be analytic if it satisfies the CR equation, so which is known as Cauchy and Riemann equation, so which is given by dou u by dou x equals dou v by dou y, and dou u by dou y equals minus dou v by dou x. So this is CR equation in Cartesian form. Similarly, one can think of CR equation in polar form. That is, if an analytic function f of z is expressed in terms of polar form, that is polar variable r and theta, the corresponding CR equation is given by dou u by dou r equals 1 by r into dou v by dou theta, and dou v by dou r equals minus 1 by r dou u by dou theta. Now using these basic ideas, we are going to select the analytic function from the given 4 choices. So in the first choice A, we have log function, and if you find derivative for the log function, you are going to get 1 by z, and the derivative clearly does not exist at the point z equal to 0. So therefore I can say log z is not differentiable at z equal to 0, implies log z is not analytic at z equal to 0. So therefore log z is not analytic over the entire complex plane. So first option is ruled out. Coming to the second option, option B, e power 1 by z. Again, you take the function e power 1 by z and differentiate with respect to z. You are going to get e power 1 by z into minus 1 by z square. Again, at the point z equal to 0, the derivative does not exist. Therefore, I can say derivative of e power 1 by z does not exist. Therefore, I can say e power 1 by z is not analytic at z equal to 0. So therefore I can say e power 1 by z is not analytic over the entire complex plane. Coming to the third choice, 1 by 1 minus z. If you find derivative of this function, you are going to get minus 1 by 1 minus z the whole square. Again, the derivative does not exist at the point z equals 1. So therefore I can say the function f of z equals 1 by 1 minus z is not analytic at z equals 1. So therefore I can say the function f of z equals 1 by 1 minus z is not analytic over the entire complex plane. So the last choice is cos z, and differentiation of cos z is minus sin z, and the derivative of cos z, that is minus sin z, exists at all points on the entire complex plane. So f of z equals cos z is the function which is analytic over the entire complex plane. So therefore option D is correct. F of z equals cos z is a analytic function which is analytic over the entire complex plane. So we are going to the second question. The real part of an analytic function f of z, where z equals x plus jy, is given by e power minus y into cos x. The question is, find the imaginary part of f of z. And we have four options. Option A, e power y into cos x. Option B is e power minus y into sin x. Option C is minus e power y into sin x. And option D is minus e power minus y into sin x. Now again it is a multiple choice question, carries 1 mark. Now before solving this particular question, so let me share few concepts which is related to the given question. First of all, we will see what is harmonic function. A function u of x comma y is said to be harmonic if it satisfies the condition uxx plus uyy equals 0 and there is a relation connecting harmonic function and the analytic function. So for an analytic function, for every analytic function, the real and imaginary part must be harmonic. And coming to the question given, real part of the analytic function f of z is given. We want to find what is the suitable imaginary part of the given analytic function. Now let us take the real part of the analytic function be u. U equals e power minus y into cos x. Now I can differentiate u partially with respect to x. So when I differentiate u partially with respect to x, e power minus y is constant. Differentiation of cos x becomes minus sin x. Similarly, you differentiate the function u with respect to y partially. So when I differentiate u with respect to y partially, cos x is constant. Differentiation of e power minus y is minus e power minus y. Now we know that every analytic function satisfies CR equation, that is Cauchy-Riemann equation. So let me appeal Cauchy-Riemann equation to find the imaginary part, suitable imaginary part for the given analytic function f of z. So let me use the first CR equation, first condition of CR equation, ux equals vy. Now using this ux, we are going to find what is v. I know what is ux. Ux is minus e power minus y into sin x, which is equals vy. Now to find v from vy, we are going to integrate with respect to y on both sides. So when I integrate vy with respect to y, I am going to get v. On the other hand, we have integration of minus e power minus y into sine x with respect to y. So with respect to y, we are going to treat as x as constant. So sine x is constant. Integration of minus e power minus y is plus e power minus y. So therefore, my v is going to be e power minus y sine x plus integrating constant. Since we are dealing indefinite integral, that is limit which does not having any integration which does not having any limit. So therefore, I have to have integrating constant. So when I integrate with respect to y, the variable x is constant. Therefore, I am going to take the integrating constant as function of x, phi of x. So therefore, I got v as e power minus y into sine x plus phi of x. So from this v, you find out what is v suffix x. That is, differentiate v partially with respect to x. So when I differentiate v partially with respect to x, e power minus y is constant, sin x becomes cos x, and phi of x becomes phi dash of x. Now we can appeal the second point of the CR equation, second relation, which is u suffix y equals minus v suffix x. I know what is uy, I know what is vx. Substitute both the values. So you have minus e power minus y cos x equals minus, and my vx is e power minus y cos x, sorry, e power minus y sin x plus phi of x. And if I multiply by negative, I will get minus e power minus cos x minus phi dash of x. Now we can cancel minus e power minus y cos x on both sides. So after cancellation, I am getting minus phi dash of x equals 0. So whenever derivative of the function is 0, I can say the function is a constant function. So therefore I can say phi of x is a constant. Let me take phi of x equals c. So therefore, if I substitute my phi of x in the function v, I am getting v equals e power minus y sin x plus c. So therefore, the suitable imaginary part is v equals e power minus y into sin x plus c. So option B is correct. Now moving to the third problem. Third problem is based on residue concept. The residue of a function f of z equals 1 by z minus 4 into z plus 1 the whole cube, or option A minus 1 by 27 and minus 1 by 125, option B 1 by 125 and minus 1 by 125, option C minus 1 by 27 and 1 by 5, option D 1 by 125 and minus 1 by 5. Again, this is a multiple choice question, carries 1 mark. To solve this problem, we want to know what is the formula to find residue for the given function f of z at a given pole of order m. So let me write the formula first. So residue is denoted by RES, abbreviated as RES, of f of z at the point z equals a, where this point z equals a is nothing but it is a pole of the function f of z having order m.